Alright, now let's make the connection between the wheelbase and the body. So this time I'm gonna speed up a little bit since we have already made this connection. And let's hide everything here. And we will need the wheelbase and the body. So we'll be creating a connection between those two holes. And again, we needed to insert some spiders. And before that, we need to insert the center node for the spider. And so we need polygons. And that's polygon for the wheelbase. That's for the body. And then we're going to insert node and create. So we're going to create this node in the center of the top hole. Apply and insert another node for the top of this wheelbase. And now we're done with the polygon. Turn them off and bring back the wheelbase first. Okay, so as you can see in the slides, the wheelbase is in contact with the body. Is in actually like area contact. It's on the top circle of this. If you remember the bearing we made, it's pretty much that area. So for this spider, we will be grabbing this whole circular area to the center node. So let's create a RBE2, and again this is a RBE2 for the wheelbase. So I'm going to put this in the wheelbase collector. The source node is in the center. The target is a little bit tricky, so I'm gonna, from the top, we need to pick all the elements on the top surface first. So we can change the method to feature angle method, feature angle nodes. So this way we're picking up the element faces, and within certain tolerance of the angle between two elements, you will pick up the adjacent elements that within this tolerance. So for example, those two faces, the angle between them is 0 degrees, right? And when it comes to the edge, it's probably 15 degrees down from this face to this face. So that's the angle between the faces. So here I'm gonna change this tolerance to really small. You can say 0 or you can say 2 degrees, just in case the top is not exactly flat. And okay, so this way I'm gonna eliminate all the elements that's below the surface. So if I'm click the face now, you can see we're picking up the nodes on the top surface. So when it comes to the edge, this angle is bigger than 2 degrees between those two faces, so it will not pick them up. And however, if you look from the top, it's more than the circular area we're picking up. So we need to deselect some of the nodes. I'm gonna change this method back to no method. So this is now hand pick. If you click any node, you can pick them up. And if you hold down shift, the shift key, and the box select, you can deselect the nodes. So I'm going to deselect some of the nodes to make it approximately a circular area. Okay, it doesn't have to be exact. You can just eyeball it. So it's pretty much a circular area. Then we can click apply. So that's the RBE2 that's grabbing the whole circular area right now. Now we can create a another spider for the body. Okay, and we can hide the wheelbase. We can go to static wireframe. Now that's the spider on the wheelframe, on the wheelbase, and you can remember like how big, approximately this big. Okay, so let's create the spider for the body, and pick the source first. Go to the top, F8, and that will be approximately this big. Excuse me. So I'm gonna hide the RB2 on the wheelbase, and remember how big that is. It's about this big. No methods, no method for this, and just hand pick them. So about that area. Now we can deselect some of the nodes to make it similar to approximately a circle. So probably I need those. That'll be it. That looks good, and we can create a new collector for the RBE2s on the body. And seems like I picked up all of the nodes for the source. So I'm gonna deselect them, pick only the center for the source, and move down to the target, about this big. And my computer is slow because I'm recording the video, also because this software is not that good. Okay. Also because I forgot to release the shift key. Alright. Now this warning is if you box select this as your target, you're also selecting the source node. So it says, no, I don't want to put the source into the target. So it's not there, it's just a warning. So I'm gonna make this a more circular shape. That's probably okay. I'm gonna actually deselect those. Okay, so we can pick them up. That's more round. So we can create a new collector and click OK. And you can turn this wheelbase back on the spiders to compare. You don't have to be exactly the same. This is good enough. So I'm going to change the name to as body, and right click, edit display, change the thickness, change the color. I think we had that. We can change that to black. So that's the spider for the body. We can turn this mesh off. Now we're gonna connect those two spiders. So first we're gonna insert a axis, which is fixed on the wheelbase in this case. So we decided to fix a pin on the wheelbase. That means we cannot fix the bar onto this body. That means we need to insert a node at the center of this spider, so they will not fix to each other. Now I can hide the spider for the body, and this is the node to create a C-bar element. So element to create C-bar. Now we need auto creation for this bar because this bar is vertical and has different diameter to the wheel axle. So from top to the center of this node, on the center of this spider. That's okay. And now what we are looking at is a rigid connection from the beam and the bar to the RBE2 at the wheelbase. Now there's no connection between the top end of this C bar to the RBE2 on the body. So what we can do is we can insert a C bush again to create a joint. So type not this one. We're gonna insert, we're gonna create another element, and choose C-bush. By the way, this create element is actually the same as those 1D, 2D, 3D. So create element, you can choose 1D, 2D, and 3D. You can choose different type of element. However, there's a little bit difference in the process. Like for the bushing, you can pick multiple nodes, or you can pick 2 nodes for the bushing element. If you go for a 1D connection and you choose like C-bush, you have to choose source and target. So those 2 nodes are separated in this selection. But in the element create dialog box, they are just in one place. So that's the difference. Because for bushing, we don't really need the source or target. So this way, there's less confusion. You just pick 2 nodes, whatever the direction is. Okay. So again, for this this joints, we need a new collector because they're gonna rotate at the different axis as the wheel joints. So auto creation, select the 2 nodes for this at that spot, and then in this new collector, we're gonna change display, enable the tags. We can change the color. We can maybe use yellow or whatever that color is. So now let's take a look at what we have here. Maybe change it to another color. Then we can tell the difference. Okay. Now, any place that has SP indicating there's a joints. Okay, there's a joint here. There's a joint here, and anywhere there's no SP, that pretty much means there's that's rigid connection. So this reverse the T shape at the bottom is a rigid connection. So that means the axle belongs to this wheelbase. It will rotate with the wheelbase. As that goes the same for the axle on the wheel. They are one rigid body. Okay, now we can assign the stiffness for the second C-bush collector. This time we need to free the Z rotation. If you look at the directions, that's the Z rotation direction. Okay, and make sure this one has a coordinate system also. Since we assigned the coordinate system for the first 2, and X knows, okay, you need a coordinate system, then I will give you one. So it's automatically did this. Alright, now let's turn on the 2D and the 3D. We're actually done for this 1/3 of the unit. So this is the most important part. You have to check, make sure this 1/3 is good before you reflect them. Otherwise, all the mistakes, all the errors here will be reflected, and if you want to correct them, you're going to do that 3 times. So what's the possible problem we would have? Usually it's the connections. Okay, so usually it's quite confusing at this spot that you have coincident nodes. You have a bushing between the spider and the beam. How do you know the spider is actually not connected to the beam? How do you know that there is a bushing between them? We have a tool called show adjacent. Okay, so it will show whatever element that's directly connected to your selection. So let's try show adjacent for one of the spider and apply. Now you can see the elements, that's the shell elements that was grabbed by this RBE2, but it will not show the elements like one step more away from this. So if you pick, say, this element, it will show the elements that's adjacent to this one. So okay, and you can see it's showing that. Alright, now by the way, after you do the show adjacent, okay, even though my 2D elements are hidden, those are still on the screen. If you say I click this, I'm gonna show all the 2D elements, right? But look at this, the wheelbase is not showing up because you did show adjacent. You have to clear this again and show this again. So that's the buggy side of your show adjacent command. You have to clear this display first before you can proceed. Otherwise, it will always show that piece, the incomplete piece of this wheelbase. Alright, now we're actually going to use show adjacent to check your connection. So what we do is we're going to keep this RBE2 on the screen. Then we're going to use show adjacent to see what's connected to this RBE2. So take them all off and show the RBE2 on the wheelbase, and that's the leftmost RBE2 for that assembly of that structure. Show adjacent, I'm going to pick this up, and if you click apply, we should see what? We should see the bushing that's connected to this spider, but we should not see the bar. Otherwise, that means the bar is directly connected to this bushing. I'm sorry, directly connected to this spider. So apply. Now we see the elements, we see the bushing. We did not see the bar, which is good. So now we are going to pick the SP. It's hard to pick them because if you move your cursor, you will not pick it up. You have to wait for the 3 dots and pick in this quick pick menu. Pick this one, apply. That'll be the C bar. You just that's connected to the bushing. So which also means once you pick up the bushing, the bar showed up, and that means the bar is connected to the bushing. Okay. Now we pick up the C bar, apply. Now this time it shows this bar and the spider. That means this to the C bar is a rigid connection. Now we can do this again and again for the other side. This is also a critical spot, a critical step. So pick this one up and apply. You should only see the bushing between the bar and the RBE2 we're going to see. If you pick this up, okay, so that means this SP is between the bar and the spider. This is the way you can examine your structure. You can also do this for the connection on the top. So I'm gonna just clear the checkbox and check it to clear this show adjacent display. Alright, so my connections are good. My meshes are good. That means this 1/3 of the model is good to go. So we're gonna call this polygon up for the mesh reflection. Now let's do a copy and a reflect and pick everything up, every element up in this 1/3 of the model. You should have very close number to this one. I had 4297 in the lab, so here is 4295, which is very close. So it's fine that it's off a little bit, but if it's off very much, 100, 200, then you probably have some issues. Then the reflection plane, first time is this one. apply, and that's reflected to the other side. Alright, next we're gonna reflect this reflected third to the right side. Okay, and let's find, first let's hide those pieces. So I'm gonna click this and hide, and now we're gonna hide this piece of mesh. However, it's picking up the polygon face, so I'm gonna hover my cursor, wait for that 3 dots, and find the mesh. So I'm gonna hide those two. Then I can hide every element there. Also, it just hide some of the polygon faces, but it doesn't matter. All we need is this face for the symmetry plane. So copy and reflect again. We're gonna reflect everything here, which should be the same number as the first time. And the symmetry plane is, this time it's the YZ plane, this one. Okay, and click OK. Now we can hide the polygon, and let's show everything again, just check and uncheck. So that will be the whole model. And don't forget to merge those 3 pieces for the body, because we just reflected a cutting edge. Okay, so we can take a look at the body mesh, and you can do a element edge check, select everything, and show the external edge. You have external edge in the middle of a 2D shell, which is not good. So let's go for the duplicate nodes, find those nodes. Okay, and those are the duplicated nodes. Then we can merge them to make this mesh connected to each other. So standard procedure, go back to element edge check, tedious, show it, but necessary. Okay, and we can right click and refresh to get rid of this blue line. So you would say we're done here, right? But wait, take a look at the C-bush for the wheel axles here. Remember, for the wheel axle for the master copy, we assigned a stiffness that can make this bushing rotate only on the X rotation direction. So this wheel axle is still be able to rotate on the X rotation direction, which is not true, because this time the wheel axle is actually at degree to the X axis. That goes the same for this wheel axle. If you want to look even clearly, those are the wheels. You can see the axle is not on X axis anymore. However, they're still under the same if you right click either one of this, it's still absolute, and the X rotation is still free. So the next step, we need to create 2 extra coordinate systems, which will have their x-axis parallel to your wheel axis. So this way we don't have to change the property of the first collector. They're all free on the x rotations, but they do have different x-axis for those 3 wheels. Okay. Alright, so now let's make the coordinate systems. Okay, so to make them, we need first to show those 2 polygons for this the 2 wheelbase at the bottom. For the master copy on the top. Of course, you need to make sure you're looking at the same angle as me. For this one, the master copy, the rotation direction is right, so you don't need a coordinate system. So we just need two extra, and for those, you need to show the polygon for them. So that will be the polygon wheelbase, which is kind of hard to find. Okay, this one and that one. Okay, those two above this wheelbase. So we don't need 3D. Okay, we just need those two wheelbase below the x-axis on the negative y direction. Alright, so insert a coordinate system. That's in the insert, model preparation, and coordinate system. And here, actually we don't need to put the coordinate system on top of this. You can put it anywhere as long as the x-axis is parallel to this wheel axle. However, I put it here so just so you know, this coordinate system is for this axle, and the one on the left is for the left axle. Alright, so the type will be z, x, and origin, because we know the z doesn't change, and the origin is here. Oh, the only thing we need to change is the x-axis. Okay, so from the top to the bottom, and you have to specify them in the order from top to bottom. If you specify the x first, then you specify the origin point. Sometimes it will be pretty buggy and you cannot hit this OK button. Then you have to switch this to something else and switch this back. Start from the scratch. So the origin point will be, in my case, I would prefer for this center point here. Okay, you can put it somewhere else, as long as your x is parallel to the axle. So the z direction is still z, so I'm going to pick z from this drop-down menu. And for the x-axis, you can't pick from the graphic window. There's no such vector there. So I'm going to open this vector dialog. And here you have this option, angle to xc, which is good because we're just rotating the x. So for the first one, that will be 60 degrees. And if you click OK, you will have a review of your new coordinate system. And that's the direction of your x. Okay. So you can just click Apply. Then we have this one, the new coordinate system here, of which the x-axis is parallel to the wheel axis on the right side. Then we will do the same for the left side. So for this, and the z is already there, so we're going to specify the x-axis, open the vector dialog, and choose at angle to xc, change that to 120 degrees. Okay, so again, that's the x-axis in this new coordinate system is the same, or the parallel to the wheel axles. Now we can click OK. Now we can find the coordinate system in the tree down here, and note they have the same name. So I do want them to have different names so I can tell them apart. So I'm going to rename the first one into 60. So I know that's the one that has 60 degrees from the absolute x. And then the second one will be 120. Okay. Now we need to find the bushings. We needed to change the coordinate system, which is the first one. So that's in the first collector. The top two are the one in the masked copy, and the middle two are for this 120 coordinate system. The bottom two are at the on the right side. So for the middle two, you're gonna go to edit mesh associated data, and this is now on absolute. We can change this to Cartesian, and the local coordinate system, we can change the method to inferred in this drop-down menu. Now we can just click on this coordinate system. It says 120, which is the one we need. Okay, so that will be the x direction. So now those two bushings will rotate on this axis. Okay, and we just changed the rotation direction of those two bushings. Now we can pick the other two on the right side and edit this data, change that to Cartesian, and use inferred to pick from the graphic window. And that's the wheel axis, parallel to wheel axis. That's also the rotation direction. And click OK. Now the bushings, they have their correct direction. Okay, and they have their correct stiffness, although they have different axes. And let's take a look at what we need to do. So for the connection, it's all done. And now all we need to do is to assign the material for the mesh. Okay, so we need to assign for, let's start from the 3D. It's easier to start. So double click and monkey wrench, material, nothing there. So let's go to the library. And for the wheel, it's gonna be nylon for now. Probably we're gonna change that to polycarbonate. So we'll see. Nylon first. Okay, for the solid. And then for the 2D, we have two collectors representing two different thickness for the wheelbase. Okay, the wheelbase is gonna have a material of steel and steel, and the thickness you can get that from the CAD. It's 1/16. Okay. And for the body, this is also steel. Thickness is 0.15 inch. Okay, so we're not done yet. We still have some pins we create. So for the 1D connection, you need to define the material for the bar collectors. So the material will be steel, and we need to define the cross section. So let's see, where are those? So if I remember right, the first collector is for the wheel axles. We do have a value in the slides, which is C bar, that's between the wheel base and the wheel. That's the wheel axles. So you can type in 0.09 375. Okay, that's the radius of the wheel axle. However, we have another method. If you don't know, like I didn't remember the radius, so I can measure from the polygon. Alright, so let's click this arrow, drop down, measure this value. You can change this measure to radius and make sure you have this polygon on. Now you can click the polygon edge. That will tell you how big the radius is. And click OK, it will save the value into this window. Although it's rounded up here, but it's the accurate value inside. So once we click OK, you can take a look at this information, and it tells you the radius here. Okay, so that's good for this collector. Let's zoom out, hide the wheel, and if we click OK right now, you can see we have this geometry here, and somehow it's not shown for the other bars, so that means they're not in the same collector. So take a look. We have this bar collector 1 and bar collect 2. That's for the vertical, right? And because of the reflection, you just created a lot of the collectors. So we don't really have to have so many collectors. We can put all the wheel axles in the same collector. So this is a wheel axle. You can drag this to the first collector, and right away you can see it has a cross section defined now. So let's go for the last one. Okay, that's the vertical. So this is horizontal. That's for the wheel axles. Let's move to the first bar collector. Okay, so for the first one, that's the wheel axles, and the second one, we can use this as your vertical axles. So just double click and define the cross section. Again, you can measure that, and this time I'm just going to type in the value, which is 1/8 in radius. And the material is also steel, and you can tell from the geometry right away. And if you're not sure, you can turn on the body and take a look at the geometry. They do match each other. Okay? So the radius is correct. We need to put those two bars into the same collector. So that will be this one, and I'm going to drag to the second collector, drag this bar to the second collector. So we have those 4 empty ones. You can just delete them. Now, just to make sure everything's not on the screen, turn on the first collector for the bar, second collector for the bar. Okay. Now, so we assign a lot of materials. I don't know if I missed anything. So we can right click on this name tab, and you can see there's a material view, and it just changed my tree into a material oriented tree. So let's turn off everything, then let's try what is the steel, right? So those are the steel structure. You can expand this, you can find the collectors. And what's nylon? Nylon on the wheels. And what else? Without material, polygons, spiders, and the bushing. So they don't have material. That's correct. Now let's go back to the standard view. By the way, you can go to the physical property view. So you can find, let's say, P solid 1, right? That's the wheel. And we have two kind of shell, which is one is this, the other one is the dolly body. They have different thickness. That's why they're in different properties. So like the bars and different property for the bushing. Okay, now let's go back to the standard view, and looks like my model is good in the FEM. Okay, and also this is the last slide of this lab. So you're done here, and there's one more check you can do. So you need to find your sim, and in this sim we can do a model setup check, and you can take a look at the this window. So I have one error because I haven't assigned any I haven't applied any load here. So this one you can ignore this. Beside this, if you see any errors, then you have a problem. But it will tell you, like sometimes it will say the bushing doesn't have a stiffness, the bushing doesn't have a direction. So it will tell you you have to go to edit mesh associated data to assign a coordinate system. Sometimes it will say a mesh doesn't have a material, like we are 1D insert 1D manual mesh doesn't have a material. Then you can just follow the instructions here and correct them in the FEM. So you can go back to the FEM and do any correction necessary. Alright, this is all for LAB7. It's pretty long, and I appreciate that you watched this long here. Okay, so next lab, that'll be pretty simple. You're just applying constraints and applying load, then you can get some results. Alright, thank you.